Hello, everyone, and welcome to Calculus. This is a Shaffer Snapshot on integration using inverse sine. There is a formula that you need to know, so I've written it here for you, and I'm going to complete an example for you using these 5 steps. So step 1 is to choose u in alignment with the formula. So as you can see, I need to get this u squared here. So I look for that model in my problem, and I see a x to the 6. So I'm going to let u squared be x to the 6 and then work backwards. That would make u equal to x to the 3rd. Remember that when you take the square root of both sides, the square root of x to the 6 is actually x to the 3rd. Any even exponent simply gets cut in half. Step 2, take the derivative of u. So the derivative of u with respect to x is 3x squared. I'm going to multiply both sides by dx to move my dx to the other side. Step 3, adjust the integral with constants only to get the right du. So I do have the x squared and the dx, which is good because I'm only allowed to adjust my integral with constants, meaning I can add a 3 to it, but I couldn't have added an x squared if I didn't have one. And then I'm also going to put in a 1/3 to counterbalance the 3 that I've added to my integral. So now I'm going to complete the integral using the formula above. So this is 1/3 du, all of this is du, over the square root of 1 minus u squared. Keep in mind that a du down here is the same as a du right there. Either way, same thing. So the formula says that this is equal to 1/3 inverse sine of u. Your last step is to just substitute the original back in for u, and I have 1/3 inverse sine of x cubed. Always add c to your answer. So some people ask me, how am I supposed to recognize when this happens? Well, a lot of times it's just because you can't get anything else to work. So normally if I saw this problem, I would have let u be equal to 1 minus x to the 6. Then I would have had a nice easy integral of 1 over u to the 1/2, which I then could have changed to u to the negative 1/2 and done my integral. But you'll notice that then du dx would have been negative 6x to the 5th. And like I said, you're welcome to add a 6 to a problem, but not an x squared, which is what you would have needed because you only have, actually you would have needed an x to the 3rd because you have an x squared, and you would have needed x to the 5th. So you can never adjust your integral with more x's, only with constants. So that's how you might recognize that something went wrong there, and maybe that would get you to be thinking about, well, maybe it's an inverse trig function. So that's how you integrate using inverse sine. If you would like to see more examples and worked out practice problems, there is a full-length video, and that link is in the description for you. Have a great day.